We all know the story. A quiet garden, an apple falls, and boom, gravity was discovered. But what if that story is incomplete? What if the real discovery happened 500 years earlier? Meet Al-Khazini. In the year 1121, he wrote his famous book named The Balance of Wisdom. And inside he described gravity, and even tried to measure it. He wrote, "The weight of a body is the measure of the gravitational force exerted upon it, and this force varies with the distance from the Earth's center." Al-Khazini believed gravity changed with altitude. That weight depends on how far you are from Earth's center. He even used pendulums, levers, and water clocks to back it up. Newton's law of universal gravitation came in 1687. But centuries earlier, Al-Khazini had already treated weight as a force, not just a property of matter. That's not just poetic. That's a functional understanding of gravity, centuries before Newton. And he wasn't alone. Ibn Sina said, "The earth draws objects by a force within it." Al-Biruni believed celestial bodies might attract each other. And Al-Tusi described mutual attraction between planets. Their ideas came to West through translations, but their names were erased. If this is not stealing, I don't know what it is. Gravity didn't fall from a tree. It rose from centuries of Muslim experimentation, philosophy, and observation. Science isn't a spark. It's a relay, and gravity wasn't discovered in a moment. It was calculated, tested, and passed on. But wait, gravity isn't the only force that's been falling through the cracks of history. In fact, during the Age of Renaissance, European scholars translated Arabic scientists' texts, but often they dropped the names. Al-Khazini became a footnote, and Newton became the legend. Now let's talk about inertia. You know Newton's first law, right? An object in motion stays in motion unless acted upon by an external force. Feels so modern, so Newtonian. But what if I told you that this was Ibn Sina's quote? A Persian polymath lived 600 years earlier, way before Newton's mom ever let him go outside to sit under trees. He said that motion continues unless something stops it. In other words, he formulated inertia long before the term even existed. So, was Newton wrong? No, but he surely wasn't first. Because centuries before Newton scribbled his famous law of force equals mass times acceleration, Abu Barakat al-Baghdadi wrote that the force of impact depends on both speed and mass. That's Newton's second law in Arabic. So what's going on here? Are we saying that Europeans didn't make discoveries? Of course not. But what if they were rediscovering knowledge that had already existed? Knowledge written in Arabic, preserved while Europe was still climbing out of the Dark Ages. Let's zoom in now on light. When you see something, what's really happening in your eyes? Most people used to think the eyes sent out beams to touch the world. But over 1,000 years ago, Ibn al-Haytham said no, it's light entering the eye. He experimented with pinhole projections and reflections. He built the foundation of optics, centuries before Descartes or Kepler picked up a lens. Even the camera started with him. Still not convinced? Let's shine a light on the famous Snell's law, which explains how light bends when moving between materials. But here's something else that might bend your perception. Snell's law is named after the Dutch mathematician Willebroord Snellius, who published it in 1621, but it wasn't his. Nearly 400 years earlier, Ibn Sahl, a physicist from 10th century in Baghdad, wrote a manuscript called On Burning Mirrors and Lenses. In it, he derived the exact same law, the one we now call Snell's law, to design lenses that could focus light without distortion. He used the principles of refraction and geometry to bend rays of light with mathematical precision. And yet, his name is almost never mentioned. It gets even deeper. We all learned that mass cannot be created or destroyed, only transformed. It's called the law of conservation of mass, and it's usually credited to Antoine Lavoisier in the 18th century, the so-called father of modern chemistry. But over 500 years before him, Nasir al-Din al-Tusi, an astronomer, mathematician, and philosopher in 13th century Persia, said this: "A body of matter cannot disappear completely. It only changes its form, condition, composition, color, and other properties and turns into a different complex or elementary matter." That's conservation of mass, clear as day. The law wasn't born in a French lab. It was already written in Arabic ink on parchment under the stars in medieval Persia. And there is more. Here's a question that sounds simple but isn't. If you're on a moving ship and you drop a ball, where does it land? Galileo used this to explain relative motion in the 1600s, that motion is only meaningful relative to a frame of reference. It was revolutionary, except, of course, it wasn't his theorem. Back in the 12th century, Abu Barakat al-Baghdadi, the one stated previously to own Newton's second law, described a form of relative motion. He argued that motion isn't absolute, it depends on the observer and the moving object. He even challenged Aristotle's claim that constant force was needed to maintain motion, and suggested that acceleration, not speed, was the real measure of force. Sound familiar? Galileo and Newton get the credit. But al-Baghdadi, who may have been the first to truly grasp acceleration, is left out of the story. Maybe it's because he spoke the wrong language. Maybe he was simply from the wrong part of the world. I don't know. All I know is he was a genius. Al-Baghdadi was studying time, space, motion, all ideas that floated long before the names we attach to them today. But because his face didn't match the story we were told about who gets to be a genius, he was sadly forgotten. But how aren't there names in textbooks? Well, translation is a funny thing. When Arabic texts were brought into Europe, they were often stripped of their authors. The ideas were copied. The credits were lost. Not by accident, but by silence. Which brings us to the real question. What else is missing? How many scientific eureka moments were actually echoes? This isn't just about history. It's about how we define genius, how we choose whose minds matter, and how forgetting becomes a form of rewriting.
I'm physicist Dowdy, and this was Physics Tales. Please like, subscribe, and remember, sometimes, what's missing from a story is the most important part of all.